All right, this is a little bit of an involved problem, but what we're asked to do here is find the equations of lines parallel to and perpendicular to this line and through this point. So let me first draw a real quick picture of what we've got going on here. First of all, we have a line. It's in the form y equals mx plus b. So we know that the y-intercept is 1. That's from here. And we know it has a slope of 3. 3 means 3 over 1, and that's our rise, and that's our run. So from this point, we can go up 3 and go over 1, and we have some line here. Okay? Now, that's not what we want. We didn't want to draw it. We wanted to find the equations of a line that's parallel to that line and perpendicular to this line. But there's one given condition. The parallel line and the perpendicular line must go through the point -3, 5. So if I go out here, 1, 2, 3, there's -3, and I go up to, let's see, 1, 2, 3, 4, and you go up a little more, here's 5. I need a line that goes through this point and it's parallel to that. So it's going to be like this, and a line that goes through this point and is perpendicular to that. So it's going to be like that. So I'm trying to find this line and this line. I'm trying to find their equations. So it's a little involved here. Let's do part A first. So for part A, I'm going to be parallel to this line. So let me erase some stuff here. Okay. Y equals 3x plus 1. So part A, we're parallel. So we have some new line. Okay, it's not this one. It's some new line that's parallel. We know it has a slope and we know it has a y-intercept. And we know right now that the slope must be what? Well, 3, because it's parallel. So it's the same slope. So we can say that our line that's parallel must have that slope. Now what we need to do is what we've done before. We need to find B. Now we're given a point. So we have a slope and we have a point. So using what we've done in the past, we're going to replace our x with -3. We're going to replace our y with 5. And we should be able to get our B. Okay, that's the -3, and that's the 5. And now this is 5 equals -9 plus B. If we add 9 to both sides, we get 14 equals B. Okay, so now what we can do is we can say that the equation of our line that's parallel is actually y equals 3x plus 14. So our parallel line, notice, has the same slope. Our y-intercept is a little bit different, but that's the equation of the line. All right, next thing we need to do is do the perpendicular. To do perpendicular, part B, we again know that a perpendicular line must have an equation y equals mx plus b. But the m is going to be what? Well, because it's perpendicular, means we need to take this number, 3, we need to find its negative reciprocal. So if we take 3, remember 3 is the same as 3 over 1, we flip it over, 1/3, and we change the sign, make it negative. So this equation of the perpendicular line will be -1/3 x plus b. Now again, we know the slope and we have a point it must go through. So we're going to plug in -3 right in here for x, and it should come out to be 5. So 5 equals -1/3 times -3, we're plugging in for x plus b. And this is a good thing because -1/3 times -3 is going to give us a positive 1. So we have 5 equals 1 plus b. And now subtract 1 from both sides and you get that 4 is equal to b. Okay, now that we have 4 is equal to b, we can go back to the equation here. We know that y equals -1/3 x plus our y-intercept, which was 4. And that's it. We've found the equations of the lines that were both parallel and perpendicular to this line, and they both went through that point.